All right, let's get this started. Hey everyone, welcome to today's webinar on writing custom detections with Panther. My name is Jack Naglieri. I'm the founder and CEO of Panther Labs, based here in San Francisco. Prior to Panther, I spent 8 years as an incident responder and a security engineer at Airbnb, Yahoo, and VeriSign. During my time at Airbnb, I was also the architect for an open source project called StreamAlert. And if you've used StreamAlert, then Panther should seem quite familiar to you. The goal for today's webinar is to learn how to write Python-based detections to identify bad behaviors in your environment. When I say bad behaviors, I'm referring to any type of activity that could indicate a compromised system or a potential data breach. And we all know the consequence of a data breach. This is loss of trust with our users, millions of dollars in damages, and a lot of other bad things. To jump right in and just give an example, we're going to write rules like this. So this rule specifically will identify any laptop in our corporate environment that resolves to a domain that could be phishing. So a normal scenario here is some attacker does some reconnaissance on LinkedIn, finds some employees, sends an email trying to compromise their systems. And in this particular case, we're looking at if someone tried to phish Panther, and we're looking at some domains that are owned by Panther. So if someone sent me an email and tried to resolve to run panther.i0, for example, then this rule would catch it. And as you can notice right off the bat, Panther allows you to actually write this code directly in the browser and also test and deploy these rules as your analysts develop them. So to take a quick step back, let's learn how this system works overall. So Panther is used to centralize and normalize all of this security data that you care about as a practitioner and provides you a platform to analyze and detect for these malicious behaviors. This normalized and structured data is also persisted to a data lake, which is just a fancy way of saying S3 with some additional metadata on top of it. The benefit of this structure is that all the data is fully grouped, indexed, and queryable with SQL out of the box with no extra work required. And you also get the benefit of real-time analysis and getting really quick signal when badness is happening. So let's dive into this pipeline in a little bit more depth. This detection process starts with the creation of a log from a tool like OS Query, CloudTrail, Suricata, syslog, or anything else you have set up in your environment. These applications give really helpful context from a specific layer like the network or the cloud. To get this data into Panther, we pass it along to a cloud service like S3 or SQS. And you can also use log aggregation tools like FluentD and Logstash to bridge the gap between virtual machines, on-prem systems, or things that don't live natively in the cloud. Then once it's in one of these systems, you can onboard this data into Panther for processing. This setup through our UI includes all of the permissions necessary to read the data and gives you, the user, some configurations that you can deploy in your environment as code to replicate this in a lot of different ways. Panther Enterprise also actually includes the ability to read directly from APIs like Okta, G Suite, and Box, which have a lot of security value. And we're constantly adding more to this list. So from here, Panther will normalize and parse your logs. And this is a really important step because we need to convert the raw data into a structure that enables us to write rules and then store structured data into our data lake. And it looks a little bit like this. So for example, let's look at this S3 access log, which is essentially an HTTP style log on our S3 buckets. That'll tell us who's accessing our data, when, and then some metadata around that access. So we go from this raw, sort of ugly format to a nicely parsed JSON log. And you'll also notice on the bottom, we see some fields that are prefixed with P underscore. And these are fields that we add, Panther adds to the system that include metadata like the event time, the time that Panther actually parsed the event, and then other fields around indicators of compromise like IPs, domains, hashes that allow you to really quickly query the entire corpus of your logs or write real-time rules to detect a potential breach. So after this normalization process is complete, which can take a couple milliseconds, data is analyzed in real time with Python and simultaneously loaded into a specific table in our data lake, depending on its classified log type. So in the example I just gave, it would go into a table called S3 server access logs. And then if our rules find a match, we send alerts out to our team, who can then use SQL to analyze the stored data in our data lake and get more additional context on what's happened. You can also use this to look backwards in time even further to see, did we actually see this in the past and just didn't know about it? This real-time approach is a little bit different from what you're probably used to in tools like Splunk and Elastic, which require data to be indexed first before searching. Panther does this analysis in real time as it's actually coming across the pipeline. So let's look at the process now for creating this real-time rule. So when writing a rule in Panther, we start with a rule function, which identifies the specific behavior that we want to identify. It takes one argument of this event and returns a Boolean value of true or false. If it's true, we'll send an alert. If it's false, we'll ignore it. You can do whatever logic you want in here. We're looking at the parsed event, and generally the pattern is you're looking at specific fields within the event and you're comparing it to certain values. You can create allow list, deny list. You can import third-party libraries, and we'll go into more detail in a moment. The second function that's important when writing our detection is our deduplication function, which controls how alerts get grouped together. In this example, we're creating a new alert for each unique bucket triggered by this rule. This function also gets coupled with a deduplication period for which new events will continue to be added to existing alerts. After the window, a new alert would get created and you would essentially start that process over. And then finally, we can specify a threshold that can optionally be added before triggering the alert, which is helpful for looking at higher volumes of events, which we'll also look in our scenario. We'll use that in our scenario soon. Finally, when we get an alert, we want to control what the message is that we see as an analyst, and the title function can be customized for this purpose. So you can interpolate values from the events, or you can use helper functions to join specific context against your events. For example, if you want to map a AWS account ID to a description of what that account is, like your production environment versus your test environment, an analyst can get that signal right away. So they can have confidence that this is either a true positive or a false positive. So after our alerts are generated, as I mentioned, it's a very normal workflow for an analyst to come into the system, into Panther, see the alert in our UI, and then click through the different events related to this alert. You can also actually search with SQL to understand even more context and do distinct queries and statistics and other things that help with your analysis. The way that Panther lays this out is into specific tables for its log type. And this is helpful for really for sustainability and scalability over time. Just having everything in a structured data lake is a very common pattern that data teams have been using for a very long time. So the way that we can query this data is by a select statement. The Panther UI also has a data explorer, which I'll show in a moment. And we can do similar types of filtering that we would do in our rules. So, in Python, you would do, bucket equals test public bucket or whatever it is that you're looking for. But in SQL, it's a where clause. And our data actually gets grouped into 3 different databases. So one of them is the Panther logs database, which is every normalized log that's come through the system. The second one is Panther rule matches, which is a subset of those events that matched any of our rules. And this is really, really helpful for looking back at our past events that had triggered previous rules and understanding if this is behavior that we've continuously seen. And then finally, the other database is Panther views, which is metadata over all of these events to enable threat hunting. So as I mentioned before, part of our normalization process is pulling out these IOCs. And with the Panther views, you can take an IP address and identify all the hits in any of our log types where it may exist. And there's actually a feature that we're shipping very soon called our indicator search, which does this essentially in the backend for you. So as security engineers, we always want to write the best possible detections, and we want to get the least amount of alerts. Ideally, we don't get any alerts ever. But this framework that I'll walk through, I think, is a helpful thought process for getting started on writing new detections. So I'd recommend starting with a framework, something like MITRE ATT&CK, which has different TTPs based off of different layers of the kill chain. And let's say specifically you want to pick one specific TTP, like persistence, and we want to identify if a system is compromised. What are some techniques that attackers use to establish that persistence and keep it? And then what we do is using an understanding of what this behavior is, we'll look at our environment and look at what's been happening in the past. Every company is different, every environment's different. So this is a really critical step to just understand as the analyst what is normal. And then you'll take this information in this context and write your rule with that. Finally, you want to test your rule. So testing can have a lot of different, you can test in a lot of different ways. One of them, which I'll show, is with our UI by creating test events. And then you can ensure that this rule would actually fire when the bad event happens. And then finally, once we get more alerts, we can feed this back into the system, we can tune our rules, and we can redeploy it within the UI itself. And then that way we have less alerts, less alert fatigue, and we just have a more accurate rule. So let's take all these concepts and put it directly into practice with a real world scenario. So for this first scenario, I'm actually using something that happened. And let's write a rule that identifies a rogue employee who terminates 100 or hundreds of systems in an AWS account. This actually caused millions of dollars of damage and really crippled that environment. So let's look how we can identify this behavior as it's happening in Panther. Sometimes an attacker will do this in a very slow, gradual mechanism, or they'll just do it all at once. So we'll look at a couple of different techniques that we can do to find both of those scenarios. So for this, we'll use CloudTrail data, which looks at all the API calls into an AWS account. And the patterns that we'll really look for are the terminate instance API calls. We'll look at a high volume of those. We saw that the attacker had wiped out 456 VMs. We'll also look for API calls from IAM users specifically, which may not be as applicable depending on how you set your accounts up. And then we'll look at the calls that are successful, because CloudTrail is logging everything, regardless of if it's successful or not. So as I mentioned, the first step is to baseline our system. And using the data explorer that is available in Panther Enterprise, we can query our logs, our Panther logs table, and get an understanding of who is terminating systems normally and what are the common attributes of those logs. We'll use those attributes to create samples for our rule and use it in our unit tests to make sure that we're covering the right use cases. So when you're creating new rules in the Panther UI, you'll go to the log analysis rules page, you'll click create new rule, and then you're presented with metadata about the rule. And the metadata is just an understanding of why does this rule exist? What's the severity of it? Which logs are we analyzing? And it just gives the system a basic set of settings to analyze in real time. Specifically, let's hone in on the dedupe period and the threshold. So again, the threshold means we're only going to send this alert if there's 10 or more events. And then the dedupe period says we're going to group those events within a 15-minute window, and then after that window, we're going to start a new alert. And then if we scroll down, we have our in-browser IDE, and then we put our logic. So we're looking at an event name of terminate instance, and we're saying no error code has been returned from this API call. And if this rule returns true, we'll get an alert either in Slack, PagerDuty, or whatever our team has set up for alerting. We'll get also a title of, some user has terminated a high volume of EC2 instances, which, looks pretty bad. And then finally, we're grouping based off of the ARN of this user identity, which could be a IAM user, it could be an IAM role, and you can customize this however you want. So coming back into the unit testing part, so what we can do is we can take certain things from our first baseline search, and then we can create these test events that cover both positive and negative use cases. So we wouldn't want this alert to fire if someone had tried to terminate an instance and it failed. We want to look at actually valid terminations. So that's one case that we can cover here. And then we can actually also cover our positive use case, which is someone terminates an instance and it actually works. We can run all of these tests in our browser as well. And then every time that you go to update a rule, these tests must pass before you save the rule, which protects against regressions over time. And also, this rule can become more complex over time. It can have more conditions. You can add more use cases, test cases, I mean, and the rule browser really accommodates all of these different life cycles over time. So if we see an alert in our browser, if we see an alert in general, it'll send something to Slack, and we'll see an alert like this. So the screenshot that I'm showing here is from my own personal deployment that I have set up, and you can see that there's a new alert. It shows the interpolated title, which shows my username has terminated some high volume of EC2 instances, and you can click into the Panther UI, and then you're taken to an alert overview page that allows you to browse the events. It allows you to click into the Data Explorer again and get that SQL search, and then start your analysis. So that's the first scenario. Let's shift gears a little bit and talk about something a little bit even more interesting, which is malicious crons. So for those unfamiliar, cron is a system within Linux that allows you to schedule periodic jobs that happen. And it's generally used for system administration, like cleaning up log files and making sure that systems stay healthy. But it's often used by attackers to establish persistence. So it's generally seen as making calls over the network to download malware, to execute some malicious payload that could be stored even in DNS records, as the second example shows, or could just be starting a netcat listener to give an attacker remote access into the system. To detect this type of behavior, what we'll do is use a tool called osquery. And for those unfamiliar, osquery is an open source project developed by Facebook that expresses the operating system as a set of SQL tables. And this specific query that we're looking at is the select all from cron tab query, which will tell us if our system has any of these crons set up, and then it will give us some attributes around that cron, such as how often does it run, which user created it, things like that. The pipeline to get this data out of osquery looks a little bit like this. And for those who are familiar with osquery, there's a lot of ways to slice and dice this. osquery has this plugin called AWS Firehose, which was actually developed during my time at Airbnb by Airbnb. And we used it to write out logs directly to Firehose, which is a message bus in Amazon that allows you to bulk write data to some data store like S3. So all of our nodes can write these logs to S3, and then you can connect those buckets to Panther using our UI, and then you can start reading the data from your nodes directly. So this is actually a built-in rule that we have that's open source. And as you can see, it's much more complex than the first one that we wrote. So let's break down each individual piece. So we're importing some standard libraries at the top, FN match, which is helpful for pattern matching. So if you want to do glob-based or just file-based pattern matching, you can use FN match. You can also use regular expressions if that's what you'd prefer. Again, this is one of the huge benefits of Python is you can really do whatever you're used to. We're also importing a library called Schlex, which allows us to parse out individual command arguments. And this is especially helpful when you're looking at cron. So what we're doing is we're actually declaring like, what are our suspicious cron commands that we care about? So we're looking at, things like curl and dig and netcat and wget and these things that normally wouldn't be in cron jobs. And then we're also looking at arguments to these commands. So we can say, if someone's piping the output of a wget command into bin sh, then that clearly looks like someone trying to establish persistence. And then what we have, again, and this is our rule function, we're taking in one argument of event, and we're doing some logic to determine, one, that we're looking at the right OS query data, and then two, that we have the right fields in the event to actually do the analysis. And then finally, what we're doing is we're saying if either a suspicious command exists in the cron or there's a suspicious argument in this cron, then we want to fire an alert. And then again, under that, we have our deduplication period, which is looking at the host. You could dedupe based off of the specific cron command if you wanted to, or you could actually leave this blank and it would just dedupe based off of the title. So if we have our system all instrumented and set up, we do cron tab -L, and then we see there's two existing crons. One of them is a wget. The other one is an S3 sync. The S3 sync doesn't match any of our rules, so that one wouldn't fire, but the second one would. So then what we see in Panther, we get our Slack alert as we normally would, or our PagerDuty or whatever we have configured. Then, we click into the browser, we see a suspicious cron found from this IP, which if we go back, we can see that's exactly what we interpolated in our title function. And then we get some other information. So we get a quick runbook, which is look at the command, analyze it, make sure that, it's actually bad and not something legitimate that our ops team is doing, which sometimes happens. And then we can see our deduplication string that was interpolated. So this is the actual host that we care about. And then we see the exact command that was shown in the first screenshot, which is this wget to, some place. This is just Google. Obviously, Google is not malicious. Their slogans don't be evil, so we can ignore that one. And then we see the path where this cron exists. So Ubuntu, so this is the root user of the system. So if this was actually wgetting something malicious, this would be a really serious finding. And then again, what we can do is we can click through to our data explorer, and we actually get a query that's crafted already for you, which you can change. You can filter it for specific fields. I'm looking at the calendar time, the host ID, and then some information about the cron. This is really helpful if you have hundreds of hits on an alert, because you don't want to necessarily just like click through all of them individually. You want to be able to write SQL on top of these events and extract some more insights, some statistics, things like that. And yeah, that's essentially it. I mean, that's the process. So, with Panther, I mean, there's a lot of really easy ways to get these pipelines going. And there's a lot of different ways that you can set up your systems to send this helpful data. And there's a great ecosystem of tools that we support today. So Panther is an open source project. You can download our community edition and you can get a lot of these pipelines going today. It takes about 15 minutes. We also open source all of our detections. So on our Panther analysis repo, you'll be able to see some of the samples I showed today, and you can get a sense of what our developer-oriented workflows look like. I didn't go through those today. We're actually going to save that for a different webinar. But if we zoom out a little bit and just look at, why is this approach really helpful going forward, just in the security industry as a whole? So first, Panther is very cloud first. We're built for modern companies that are running in Amazon. And this is, most companies today. The second one is structure. So being able to parse all of these logs on write and do this normalization for you has a ton of value, both for the ability to write really awesome and flexible rules, but also storing petabytes and petabytes of logs over time. Generally, security breaches go unnoticed for months or maybe even years. So having this database and this structured data lake rather will be really sustainable over time. And then speed's really helpful. So as engineers, we want to know right away when things are happening, because every second counts in a breach. So we do our analysis in real time, and then we also allow you to look backwards in time with SQL. Panther is actually built fully on top of serverless. I didn't mention this really at all, but the architecture is based off AWS Lambda, which means that it just elastically scales as you feed it more data. And this is really helpful just because you can run Panther with a really small ops team, and you can really accommodate any scale that you're at, whether you're doing 100 gigabytes a day or 10 terabytes of data per day. And then accessibility. So, most engineers love Python. I personally love Python. I think it's a great language for writing detections. And I think SQL is equally great for understanding what's happened in our environment and doing joins between tables and hunting for certain behaviors, things like that. So this is the first in a 2 or 3 part series, and in the next installment of these webinars, what I'll do is cover our CLI workflows, which look at how to really incorporate developer-oriented CI/CD pipelines, things like that with Panther, and auto deploy rules, and just do things on a more team-based level. We'll also look at DynamoDB caching, which is a little bit more advanced in terms of creating state between rule invocations, things like that. We'll look at actually using these standardized fields that I talked about in normalization, and then making custom API calls before we actually generate our alerts. And I think what we'll do now is just open up for questions and Q&A. So if anyone has questions, cool, okay. Can we get access to the slides? Yes, we will send those out after. Question number 2, I'm in a company that is hybrid cloud multi-cloud. Does Panther have me covered? Yeah, so the approach I would suggest here, and I'm assuming, let's see, what is your second cloud? We're bigger in AWS, but we're trying to gain better visibility for on-prem Azure and more. Yeah, this is a great question. So you can deploy Panther into an Amazon account, and then you can actually centralize all of your different log data, whether it's from VMs in Azure, VMs in GCP. You can port it over to Amazon using tools like FluentD. It's not as elegant as if you did it in Amazon, but it's certainly possible. FluentD actually also has the ability to pull from those clouds. So FluentD has a plugin for, I know, GCP's PubSub that we've used. It may also have access for Azure. And again, really to get it into Panther, it just has to land in Amazon in some way. So I would recommend, building your own tool that would just put it into S3, or using something like FluentD and some of the rich plugins that FluentD has available. Are there plans to integrate some type of AI for baseline threat detection as well as user behavior monitoring? Yeah, these are great questions. So as of today, we're focused really on deterministic based analysis. We want to cover most of the use cases that we as engineers know are bad, and Python's a great way to do that. I think in the future we will start to invest a little bit into machine learning, but it's definitely not a priority this year. And let's see, is anyone okay? Okay, all right, another question. Can you import logs from Jamf? I haven't experimented yet with Jamf. If they can send, let's see, we don't have native support for Jamf. If Jamf is using some type of cloud service, we could build an integration to pull from that. If it's centralizing logs on an on-prem system, we could use a log tailer like FluentD and get it into S3, which then could be written out to Panther. We also have an upcoming feature around custom logs. So you'd essentially be able to define whatever custom log type that you have in the browser, and then it would pull it into Panther and store it in the data lake. But yeah, that's a great question. Any other questions from the audience? Again, thanks so much for your time. We can, unless anyone has any other questions, we can just end here. And again, we're planning to do another installment of this series in the next 2 weeks. So you can go to runpanther.io. You can sign up for that one as well. feel free to reach out to us on Slack as well. So if you want to join our community, we have an open Slack channel. We can take questions there as well. We actually just got one more. What measures have been taken to control, monitor Python code injections? Yes, it's a great question. That a malicious user or threat actor can exploit using Python editors. Yeah, so we actually had the entire platform pen tested to, protect against whatever attacks that we really, were really reasonable in this type of scenario. All the lambdas are very locked down, so they really can't do too much. But at the end of the day, if someone got access to the system, I mean, that's that's always an issue. And I think if you have access to the system, access to the Python is probably the least of your worry. But an attacker trying to modify the code from the outside can't be done. And we're happy to actually give more context on that if you want to follow up with us on Slack. Cool. I think we can end here. And then again, if anyone has any questions, just reach out to us on Slack. Thanks so much. Again, my name's Jack, and hope to see you all again very soon. Thanks.